Okay, Diane France, are you, yes, you are there.
I am here.
Good, very good. Well, I think we'll go ahead and get started with our program tonight. And we're very, very fortunate to have Dr. Diane France here. I'm happy to be able to introduce her. And I'd like to just give you a little bit of her background. Her longer bio is available on our website and on our social media site. But to get started, I want to do a little bit of a shortened version. Dr. France received her Ph.D. in anthropology at the University of Colorado, Boulder, in 1983 with an emphasis on forensic anthropology and osteology. In 1989, the American Board of Forensic Anthropology certified her as an expert in forensic anthropology. She has been recognized as an expert by multiple Colorado district courts, as well as in Wisconsin. She is an adjunct faculty member of CSU and is the owner and director of the Human Identification Laboratory of Colorado, an independent laboratory, and I believe that's located in Fort Collins. Is that correct?
It is. Yes, that's right. Mm-hmm.
Dr. France has experience in archaeological techniques, particularly as they relate to recovery of human remains and evidence from outdoor scenes. And that is what we're very interested in here tonight, to hear tonight. She is a member since 1989 and past president of NecroSearch International, a volunteer multidisciplinary organization that assists law enforcement in the location of clandestine graves and the recovery of remains and evidence from outdoor scenes. And she's going to talk to us tonight about the circumstances surrounding death. And I'm going to turn the floor over to Dr. Diane France.
All righty. Let me get everything set up. I hope that this is going to work. I'm having a little bit of band issues with my internet here, so I'm keeping my fingers crossed that this is all going to work. So what I wanted to talk to you tonight about were the circumstances surrounding death and forensic anthropology. And we'll be talking about gunshot wounds, sharp injury. This is actually from a dismemberment case. We won't really talk so much about dismemberment tonight unless you decide you want to. I'll go anywhere you want to with this talk. But we will talk about sharp injury in other situations, talk about blunt trauma. And then we will also focus on this case. This is a very interesting case out of Weld County in Colorado, just east of Fort Collins. So the first thing I guess I probably should do is talk to you about what a forensic anthropologist does. And then we'll talk here in this slide about what a forensic anthropologist does not do. But a forensic anthropologist uses skeletal clues in a couple of ways. One is to determine the sex and age, ancestry, stature, some idiosyncrasies of the body that help to identify an individual. You know, everybody says that that DNA is the be all and end all of human identification now, but actually you can get DNA out of a body, but you don't have anybody to compare it to currently. And so it takes a forensic anthropologist to determine the age and sex and ancestry and so on, so that the medical examiner or law enforcement can narrow the field of possible victims, so that then they can take DNA from family members or from a comb or a brush or toothbrush or something like that and compare it to the body. So we get that process started. The other thing we do is what we'll talk about tonight, and that is determining the circumstances surrounding death. We also do, many of us also do what you were talking about before, which is to help law enforcement look for clandestine graves and to help recover evidence, including human remains from those graves. But let's talk about the circumstances surrounding death. So I'm sure you've all heard about and written about, undoubtedly, the cause of death and manner of death. The cause of death is the physiological reason for death. Either you have a heart attack or you have a gunshot wound or something like that. But it is the physiological reason for death. Manner of death is split into 5 different categories: natural, accident, suicide, homicide, and then undetermined. But a medical examiner or coroner determines these. Forensic anthropologist does not. We do not determine the physiological reason for death. We cannot, I mean, I can guess that the manner of death was homicide, for example, just based on the circumstances. And so I will tell the medical examiner or coroner in my report that, hey, look, he's got a gunshot wound in the back of the head, and I can't tell for sure that that was the physiological reason for death because I don't have any soft tissue. Or if I do have soft tissue, I clean it off of the remains as quickly as possible because, frankly, soft tissue just gets in my way. So that is determined, the cause and manner are determined by the medical examiner or coroner. We determine the circumstances surrounding death. We have to talk about several different categories here. We have to talk about antemortem, which is before death. And I'm probably going over things that you folks already know about and write about all the time, but I need to get into this just a bit before we continue. Antemortem is before death. Perimortem is about the time of death, and postmortem is after death. These terms are different when defined by a pathologist versus a forensic anthropologist, because in soft tissue, the pathologist is determining all of this by looking at the soft tissue. But like I said, soft tissue just gets in my way. And so antemortem is before death, and that is when you show either signs of bruising, you show signs of healing potentially, you show signs of infection. Perimortem is about the time of death, and that is determined, it's a snapshot that a pathologist uses, a snapshot in time that is based on the cessation of a vital reaction. So as soon as the heart stops beating, that is, if you have an injury or something right about that time, then that is determined as perimortem. Postmortem is after death, and you don't get bruising, you don't get active bleeding because the heart has stopped. You don't get any kind of infection. So like I say, that perimortem time, that time period is a snapshot in time. For a forensic anthropologist, we determine all of this by looking at bone. In antemortem, before death, we should have signs of healing. I'll show you in just a minute in bone. We can see some signs of infection, but you can have antemortem that is maybe 5 minutes before death or an hour or 2 before death, and we won't be able to determine that happened, you don't have infection that would affect the bone 5 minutes or 2 hours before death. So we would not be able to determine it with that snapshot kind of precision. Perimortem, or about the time of death, is determined more by the fracture pattern in bone than it is anything else. And I'll show you examples of that. And postmortem is after death. Postmortem for us is a window, a really sometimes wide window, perimortem and postmortem, and it's not a snapshot. So I'll show you some examples of that. So this is an antemortem injury in bone. This fellow on the left was hit by a train, believe it or not, and he survived for about 10 years before he finally succumbed. He wasn't quite right, but he survived for 10 years. And the way that you can determine that is by looking at the rounded edges around the injury. You can also see some radiating fracture lines, some evidence of radiating fracture lines away from the injury itself around in here. And also you have a broken zygomatic arch down here, but you can see that those are really pretty well healed over. So that would be, this is an antemortem injury because there was significant period of healing before the individual died. This is a perimortem injury, and it is characterized by really sharp edges in the injury. This is a gunshot wound from the Civil War, as a matter of fact. And this is the exit wound. We'll talk more about entry and exit wounds here in a second. But you notice the really sharp edges? That for us is a perimortem injury. Okay, so let's look at this fellow. This is a Peruvian. This is a cast of a Peruvian. And you look at the back of the cranium, you see some holes here. Anybody know what those are? I don't know if Yeah, this is probably not going to work for us to do this, but these are trephinations. This is a prehistoric surgery. So an individual, the surgeon, took a stone tool and just incised the bone this way and that way and this way and that way until they could finally take out that plug of bone. There's there are a couple of really interesting clues here. One is, do you see this line? These lines that are going around here? That is the sign of where the scalp was reflected. And these are signs of infection in this individual. So this is a perimortem injury though, because you don't see very much a rounding of these edges here. So it's perimortem within a day or two when we can actually see the infection in here. There's another one up here as well. One of the interesting things about trephination is that, you know, the anthropologists, when they see something that they just can't explain, they often say, oh, well, it has to have a spiritual reason. You know, if we're not smart enough to figure it out, then they probably aren't smart enough to do something, anything other than spiritual. The more we look at these individuals, the more we're seeing things like this, a previous injury. So it could very well be, and a much better explanation for this could very well be that they are trying to do what we would do with a trephination, what modern surgeons would do with a trephination, which is to relieve pressure on the brain and not release evil spirits or anything like that, but just a normal physiological reason for doing a surgery like this. But when we have an injury like this that has really not much in the way of rounded edges, we do look for things like in the process of reflection of the scalp or reflection of the skin. So what is bone? We need to get into this to really be able to explain the fracture patterns in bone and whether or not they are perimortem or postmortem. Bone has two different components. Everybody thinks of bone as a really rigid structure that we hang all the muscles and organs on. It does have a hard tissue component, which is primarily calcium phosphates, but it also has a soft tissue component, which is a cartilage that is interwoven among the hard tissue component. Now, one of the things that is really kind of cool to do, I don't know if you've ever done this or not, but one of the interesting things to do with your kids or your grandkids or just to do yourself is to put something like a bone, a chicken drumstick, and it's put into vinegar or some other kind of a weak acid for a couple of weeks, and it will dissolve away all of the hard tissue component, all of the minerals, so that all you're left with is just this cartilage. And what this does is to point out the really unique feature about bone, and that is that it bends. Even when you add that mineral component back into this, the bone still bends to a certain extent before it reaches its elastic limit. When it fractures, it reaches its elastic limit. Some of the bone fibers, and I'll show you this, I'll show you photographs of this, some of the bone fibers will still remain bent. So if I'm looking at bone and I see those bent fibers, then I'll say this is perimortem. And the definition of perimortem here is that that bone will have the same ratio of the soft tissue component, the collagen component, to the mineral component. And as long as that bone has that same ratio, then it will bend before it fractures. Now, this adds kind of a complication to a forensic anthropologist, because if you have someone who has just died, and I can tell you for a fact that this chicken is post-mortem, okay, obviously, I ate it. And so if this chicken has that that soft tissue component still at the same ratio with the mineral component that it will bend, then I would call that a perimortem trauma. I would call that perimortem injury and not post-mortem. One of the problems when I end up in court, when I'm testifying in court, is that if I say, well, yet this blunt trauma is perimortem, a smart defense attorney would ask me, well, Dr. France, you say it's perimortem, could it have occurred a day after death? Yes, it could, because that ratio, that soft tissue to hard tissue component ratio is still the same. Could it have occurred a week after death? Yes, it could. Could it have occurred a year after death? Potentially. depending on the environment. If it's lining up in Colorado, you could potentially have at least a long season where you would have that same ratio where it is not decomposed away. And so you have that bending potential in that bone. So that would be an interesting thing to bring into one of your mysteries, one of your stories. If you could catch somebody saying that a perimortem trauma, it's perimortem and no, it can't have occurred a day after death, and then not be able to give an explanation for it, because it can occur a day or 2 or 3 after death. Now, one of the things that determines how much of that soft tissue component is still in the bone, when a body is decomposing, if you're laying outside in a field in Weld County, as your body is decomposing, the soft tissue decomposes away from the top of the bone first, right? Well, then that soft tissue component decomposes out from inside the bone. And once that has occurred, so that you don't have much of that soft tissue component left, then you will get a type fracture. So what's the difference? A perimortem type fracture, I'll show you, but you have these radiating fracture lines like what we saw a remnant of in the one cranium. If you have a post-mortem fracture pattern, it would be like you're going out into the field someplace, you find a cow skeleton that's bleached white, and you hit it with a hammer and it just splinters. A fresh bone won't splinter like that, but a post-mortem fracture will. Okay, so how does bone fracture? Bone will fracture at tension before it will fracture at compression. So if I have this pin and I'm trying to bend it to break it, my thumbs are exerting compression forces. The tension forces are up here. Okay, so if you're looking at this diagram here, the compression forces and the direction of force is coming in like this, but the bone will fracture first at tension. This is really important because then you can tell some things about accidents that occur, for example, between a car pedestrian accident. If you have somebody who is a witness who says, yes, the victim was facing the car facing away from the car, and the driver says the victim was facing toward the car, then you can use this fracture pattern to determine who's telling the truth. So I do some things for little kids. I did this for a 5th grade lecture that I gave, and these are drumsticks, and I tortured drumsticks in all different kinds of ways. You'll see how I did it in crushing forces in a little bit. But the compression is here. I hit it with a hammer. The compression is up above, and then the tension forces are down below here. Okay, so it's fracturing first at tension, but it has a very, very characteristic kind of fracture pattern. It fractures here at tension first, and then it forms these sidelong fractures like this. A colleague of mine calls those butterfly fractures, and I'm not quite sure how he came up with that, but that's what everybody calls them now. So, and then there's the completed fracture. One of the things I want you to pay attention to, though, you see down here how the fibers are still connected to the main part of the bone, but yet they're kind of bent. That's characteristic of a perimortem trauma. This is a real case of a car pedestrian accident. Okay, this is the tibia, or the lower leg, and you're looking at the front of the lower leg. Okay, so from which direction is that force coming? From which direction did that car bumper hit that individual? From the right. Okay, because it fractured first here, and then there are those characteristic fracture patterns, that wedge that comes out like this. It's just like that wedge is pointing in the direction of travel of that force. Okay, now this is really an interesting case. During the Civil War, and I'll just show this to you, I don't expect you necessarily to read all of this, but during the Civil War, the soldiers who were injured in the battle were taken to a field surgical hospital, and they would treat the individual usually first with an enema, literally with brandy and an enema. And then if the individual died, then they would cut out the section of bone that they thought was affected by the usually gunshot, by usually muscle fracture. And this individual was injured and he was brought to the field hospital, and they noticed that he had a scalp wound, but he didn't have any other kind of a wound. They felt around in that wound with a finger. They couldn't find any kind of break in the cranium at all, in the skull. And so they thought, well, okay, we'll just bandage the injury and send him on his way. Well, he started to really just go down in quality of health. And finally he became comatose and he ultimately died. And they couldn't figure out exactly why, because he didn't have any kind of a real skull fracture. Well, then they looked at the other side. So he was hit by the mini ball on the outside of the cranium, the inside of the cranium, the place where you get the tensile forces, the inside of the cranium was what fractured. Okay. This is a modern case. This is a fellow from outside of Denver who was attacked with a hammer. You can see that you've got some fractures here, some indentations, compression forces with the head of the hammer, and then you also have some other areas here, like that was the claw of the hammer. Okay, you've got a claw hammer right here. You've got the claw side here. You can see an indentation, kind of a square side indentation. You've got two claw right here, two claws. A lot of fractures, just a whole lot of fractures. This guy didn't have. If you look at the inside, right in here, right here, and you have those tensile forces again. Okay, now I've beaten that into the ground. You can also determine something about the sequence of events. The sequence not only in blunt trauma like this one, but also in gunshot wounds. So you have two gunshot wounds in glass here, and you have these radiating fracture lines. There are two different kinds of fractures that occur with a gunshot wound. And they don't necessarily occur with every one, but there are two characteristic kinds of fracture patterns. You have the radiating fracture lines that radiate away from the point of impact, but you also sometimes get these concentric fractures that circle around the injury. And sometimes, especially in high caliber bullets, you get these concentric rings that start out small that are fairly close to the entry, and then they get bigger and bigger, kind of like dropping a pebble into a pond. Well, if I'm missing part of this cranium here, I can just trace back those concentric rings until I can figure out pretty closely where that entry wound probably was. Okay, so I have two fractures here, two gunshot wounds. Which one occurred first, D or M? The answer is M, occurred first, because its radiating fractures are free to just completely go for as long as they have force behind them. Once that force is dissipated, then they'll stop. But after D, his radiating fracture lines are stopped by M. Okay, they're intercepted. So M is first and D is second. This fellow was from Colorado. This is a case from many years ago. He was part of a threesome, and two of the threesome decided that they didn't want him in the party anymore. And so they killed him. This was kind of an odd case too, because he was buried in a shallow grave outside of Pueblo, and a divisional wildlife fellow decided that he wanted to go fishing one day. He had permission to cross this private land, and he opened the gate. It was one of those old barbed wire gates that you have to release the top wire and then open the gate, drive through, and then come back and close it. So he got out and he opened the gate. He just about got back into his pickup, and he looked over and he saw a hand sticking out of the ground. So he did what every reasonable law enforcement officer should do. He got a shovel out of his pickup and started digging. Not the thing to do. So he was digging around, and he had quite a bit of this body exposed and taken out of the grave when he took one more swipe with the shovel and heard this thunk and decided he probably ought to stop at that point. So he called the sheriff and called the coroner. They went out and they called me. I went out, I went down to outside of Pueblo and started, and I walked into the scene and there are body parts laying all over the place. This guy was pretty well decomposed. So I started trying to make sense of everything and do a responsible excavation. When I got his body back to the lab and I was cleaning it off, I could determine that where he had hit the cranium, he had hit it right at the top of the cranium here. And one of the reasons that I can say that is that when a body decomposes, the bone kind of absorbs some of the color of the dirt, but also the color of the decomposition. And so if you hit that with a shovel, you have interrupted that color change in the bone. And wherever it was hit like that, it will be a lighter color. That little ding will be a lighter color than the rest of the bone. And it was in this case. So I could tell where he had hit it. This is a marvelous tool to use because if you have I have a cranium at the lab where the grandkids, grandpa died and the grandkids are up cleaning out grandpa's attic. And they went up and they found this cranium and mandible in a glass case up in the attic. And they took it out, apparently, and were looking at it. And I think somebody dropped it. I think one of them dropped it. When I got the cranium, there was a crack that ran along the outside of the cranium, clear around the back of the skull. And the first part of that had a dark color inside the crack, meaning that it had been exposed to the same kind of environment for about the same time as the rest of the cranium, which was dark. The second part of that crack was light in color. So it occurred more recently. It was not exposed to the same environment as the rest of the crack and as the rest of the cranium. So anyway, that's a little side trick there. So when I was looking at this, now this cranium was in many, many different pieces. And so I put it together as well as I could. And I started to look at some of the features on this cranium. And I think probably that it had been struck twice. I think it had been struck twice or once up here and then a second time here. But if you look very closely, there are several different clues. One is you see this little point right here. And I don't know if you can see it well or not, but there are little divots as you kind of continue down here. There are little divots, irregularities in the side. The top is really pretty straight. You also notice that down in here, which is right over here, down here, there's a scrape where the top part of the bone has been removed. The top part of the cranium has been removed. And then just a lot of fractures. So the law enforcement in the corner, and they were asking me what I thought happened. And I said, well, it's obviously blunt trauma, and it's blunt trauma with a pretty significant weapon, pretty heavy, significant weapon. But to tell you the truth, I can tell you some of the characteristics here, but I can't really tell you what did it. I've got something that has maybe threads on it. I'm not sure, or at least projections, and something that has a sharp edge that would create that scrape. And I think probably what happened is that he was hit twice, but somebody was coming down from above to hit him here and here. He also had another little divot on the side of his head that was really interesting characteristically. But so I said, so I can describe the tool to you to some extent, but I can't tell you what it is. I have no idea what it is. So they said, well, could it have been this? And that covers all of the bases. And this was missing from the basement of one of the perpetrator's houses. It's a barbell shaft with a little knurled nut here. And the side of the cranium had an indentation from that knurled nut right there. So I put that right up against the cranium. You have to be really careful when you do this too, because obviously you don't want to create additional artifacts. but I put it up against the cranium and it fit perfectly. Every one of those little divots around here, the flat edge up here just corresponded perfectly. It was just a perfect match. So with circumstantial evidence, I mean, I could not go to court and say, yes, this particular tool absolutely did this. I could say something about the class characteristics. I couldn't say anything necessarily about the very tool. But with all the other circumstantial evidence that law enforcement brought up, they presented them with the evidence, the perpetrators, the two perpetrators with the evidence, and they confessed. It's just a Perry Mason moment, you know. It was a good event. And this is showing it close up here. See some of the staining from the metal right there. So, okay, let's talk about gunshot wounds. Ballistic trauma, you have, in a classic situation, you have the entry wound and you have the exit wound. And you can see the difference between them, right? The entry wound is usually smaller. It's almost always smaller than the exit wound. And the exit wound has a beveling effect on it. Now, you can see here, you've got the radiating fracture lines. I have an interesting little tidbit for you. A colleague of mine has been doing some research and discovered he does slow motion photography, slow motion cameras on donated skulls, and he will either hit them with a bolt, you know, like you use to kill cattle and pigs, either hit them with a bolt at a specified level of power or speed, or he will shoot them with a gunshot or with a gun. And he found that when you have a radiating fracture line that circles the cranium and makes it to the exit wound, the fracture will beat the bullet to the wound, to the exit wound. The fracture will propagate that quickly through bone. Okay. Okay, this is a sad case. The two entry wounds, you have an entry wound up here, smaller, entry wound down here. This is, unfortunately, this is a classic execution style where they will make somebody bend over, you know, kneel and bend over, and then they'll shoot them at least once, but very often twice in the back of the head. And one of the bullets exited right here. This is the inside of the entry. This is the inside of this wound right here. And you can see that you've got the beveling there too. So the beveling will show you the trajectory of the bullet. This is an interesting case. This is a gunshot wound. You've got the entry here and the exit here. This is not anything, this is related to the radiating fracture lines. It created enough damage. If you have a very often a gunshot wound like this in the cranium will just cause a lot of devastation in the cranium, a lot of fracturing. So that's what this small hole is up here. And also you have another one right here. So entry wound, exit wound. Did he survive it? Hard to believe that he would, but he did. See the rounded edges? I don't know for how long he survived it. He had so many fractures. You've got a broken zygomatic arch here. Again, you have radiating fracture lines coming in here. You look at the front of the cranium, he's got just a lot of damage. This is the autopsy cut, so that doesn't count, but you have fractures here and here. He received a lot of damage. And I doubt that he was very coherent after that, but he did survive it. Okay, now let's talk about an individual that will go from basically from start to finish with this fellow. This is how he was discovered out in the middle of a field. And the law enforcement couldn't find his body for a long period of time. And this was one case when I was not assisting and trying to help locate the body. They just found him eventually, but he was out in the middle of nowhere in a big field. And this is what his cranium was like after I cleaned it up. So I went to the autopsy, and the pathologist was taking x-rays and so on, and just trying to figure out how this fellow died. And it turns out that before they found the body, they actually had 3 teenage boys confess to the crime. And the way the youngest of the teenagers who confessed was 12 years old, and he was just basically along for the ride. And he got back home and he slept on it, and he was so disturbed by it that he told his dad, and his dad took him to the sheriff's office, and he confessed to it. And he told them the other 2 teenage boys who were part of this whole thing. I think the oldest one was like 17 years old. They had seen this fellow. They were out driving around, and they had seen this man walk into a liquor store, and he walked out with a 12-pack of beer. And they decided they wanted that 12-pack of beer. So they killed him. So as we go through these slides, I will show you the different injuries on this guy's body. So here's his cranium, and you can already see you've got a big fracture here, and you can see a hint of a defect off on the left side of his cranium. Okay, this is the back of his cranium. It has approximately 50 stab wounds. So he has sharp injury all over the place. He has sharp injury on his ribs. He has sharp injury all along his back, but a lot of concentration of this sharp injury knife cuts on the back of the cranium. This is the only one that actually penetrated the cranium. And it didn't penetrate very far. It only penetrated maybe 1/16 to 1/8 of an inch. So it didn't penetrate very far. Here are some of his ribs. You have some fractures here, and you've got sharp injury here. This is the same rib here. But you have a lot of sharp injury, but you also have some fractures. The interesting thing about knife wounds in ribs is that if they are going across, if they're in line with the grain of the rib, the grain of the rib is going to come across basically like this. If they are in line with the long axis of the rib, if you pull the knife out, if it isn't a really thick blade, if you pull the knife out, it will close up again. And so it's really important for me when I'm trying to investigate this, that if I suspect any kind of cuts on, well, anywhere in the body, actually, I mean, I take a take a microscope, dissection microscope, and go over every bone in every case. But I have to clean it and then let it dry so that it'll open back up again and I can see them. But you can see the devastation in this. It's just massive. You have some fractures up in here. It's just overkill. Okay, so I'm back to torturing chicken bones again. This is part of what I was trying to show to the 5th graders. I took a 2 cinder block, a double cinder block, and brought it down on the rib, excuse me, on the chicken bone, until it fractured. You can see that it's breaking down here. By the way, an interesting thing about the bending properties of bones too is that you can hang this double cinder block from a chicken bone like this, from a drumstick with a zip tie, and it won't break. If you drop it on the chicken bone, it's gone through too much force too quickly, and it will break. But if you just hang it, it will bend it. You take really good photographs of it, and you can see that bend in the chicken bone, but it won't break. But if you do this to it, of course, it's going to crush. So this is what a crushing injury looks like in bone. It looks like a crushing injury, right? Look at this, though. I was telling you about the bending properties, that it's still connected to the bone, but it is bent, and it will never go back because it has reached its elastic limit before it fractures. Okay, you got it over here, here, and so on. So this I would call a perimortem trauma, even though I had it for dinner. Okay, notice this. So you've got some crushing injury here. You have some just regular fractures around the heads of the ribs. You also have some fractures, just some massive fractures, and this is the pelvic girdle. And you have this. Now, their story was that they went up to this fellow and they started stabbing him in the chest, in the back, in the head, which I could pick up in the bones. They said, we also, we decided to shoot him. And so we shot him in the chest. He wasn't going down quickly enough, stabbing him all those times. So we decided to shoot him. And so they said, yeah, we shot him in the chest. I didn't see any evidence of a gunshot wound in the chest whatsoever. They said they shot him once. I only saw one gunshot wound. This is the gunshot wound. You can see the radiating fracture lines here. So is this an entry or an exit?
Exit.
You say exit?
Yeah.
Like up in here? Okay, how about both? It's an entry wound and an exit wound. Here's the entry wound down here in the same hole, and it exited here. And the way it does that is that you just shot, you put a bullet through tangentially through a curved surface. So it's possible with that curved surface to have the entry wound and the exit wound in the same wound. So they were wrong. They didn't shoot him in the chest. They missed and shot him in the head. This is one of the only times I've ever seen a classic keyhole. This is called a keyhole fracture. One of the only times I've ever seen a classic keyhole fracture. And not very many of my colleagues do either. You have to get the conditions just right to be able to get a classic keyhole. And you can see over here that the x-ray is showing a little bit of the metallic white from the bullet. Okay, so there's that fellow. And then, like I said, he's got the radiating fracture lines here as well. So we can do other things too. Let me stop screen sharing here for a second. If you have a bunch of questions, we can go ahead and you can ask questions. If you have scenarios you want to run by me and get some advice on how to do it, that's fine. If you want to go on and talk about something else, about, like, for example, exhuming bodies, finding bodies and exhuming bodies, I'm happy to do that as well. Or if you've just had enough, want to go have a glass of wine, that's fine too.
Okay, Diane, this is Margaret. I think we would love to just open it up to questions, unless there are none, and then we might want to do some kind of a case study or something, whatever you're prepared to do. But we had
I'm prepared to do anything you want to do.
Okay, great. We had a couple of questions. One was the Peruvian skull that you showed.
Yes.
Someone wanted to know how old that skull was.
Oh, it's hundreds of years.
Okay.
I don't know the exact date, but it's an archaeological specimen from Peru.
Okay. And then I think Sabrina had a question about whenever you say right or left, are you talking about the subject's right or left?
Yes.
Okay.
Yes, always.
Okay. And we have a question in the chat from Kurt. How often do you work with cadaver dogs?
Very frequently, actually. So I belong to a group, and I can talk about this if you like. I have some slides in that same presentation. NecroSearch International is an organization. It's a volunteer, multidisciplinary, 501c3 nonprofit group. We have about 45 members now. About a third of our group is in law enforcement, about a third in academia, and about a third in private industry. And we help law enforcement, and we get requests from everybody, but we will only help law enforcement because we don't want to unintentionally compromise a case, to look for clandestine graves and to help recover the evidence, including remains, as we said, from those graves, but also to help locate bodies that are from what we call dump sites, where a perpetrator will take a victim and want to get rid of the body quickly. And so they'll either drive out I-70 and then just dump the body off the side of the road, or they will pick, and this is about 75% of the time, they will pick a site that they are familiar with. Either they own it, their family owns it, they hunt or fish there frequently, but they're really familiar with the site, so they feel comfortable in depositing something there. We call that, pardon me, we call that a dump site. So, but we help law enforcement in looking for these remains. Cadaver dogs are a big part of that. We have specialists in all kinds of specialties, geologists and geophysicists, botanists, hydrologists, because we get quite a few bodies that are dumped in water. So we need to know something about how the water is going to move. And also with the cadaver dogs, we need to understand how the groundwater moves too. So that if the dogs are hitting in one spot, then the hydrologist can say, well, that's very, very interesting. And you're not seeing any kind of anomalies here to suggest that a body is buried here. So let's look at the hydrology and see where that water is coming from. And it could be that the body is buried underground, so not in a running stream or anything, but the groundwater is moving down to this spot. We're also getting some hints that cadaver dogs will pick up if they're hitting on a bush or a tree or something, that they could be getting some of that scent coming up from a body that is buried that is going through the root system. That's a little bit more tenuous. We're not entirely sure we understand that whole process yet, but yeah, we have 3 handlers in neck research who are cadaver dogs, cadaver dog handlers. We have found that it is not a good idea and not very successful usually to use a dog that is cross-trained in search and rescue versus cadaver dogs versus, seeking out cadavers. They don't seem to be as good as dogs that are just trained on one thing. We have followed so many dogs that they're volunteers, they want to help out with a case. And so they volunteer to help with their dogs. And they have a golden retriever out there who's just running around in the field. And the handlers, they have it, they want to help. Their heart's in the right place. Their dog just is not any good. And I have followed up some volunteer dogs, when a body was of a transient who was trying to walk across a boggy area along I-25, and he got stuck, and it was wintertime, and he died. And the top part of his body was scattered by scavengers. The bottom part of his body, his legs from his thighs down, were still stuck in the mud, and the dogs were walking right over the top of it. And they didn't hit on it one time. The handlers were busy flagging trash instead of flagging bodies. And so we have to be really careful. I trust our guys. I trust our dog handlers. Dogs are animals, they have minds of their own. So sometimes they have good days and sometimes they have bad days. And so we always say to law enforcement, don't ever clear a site based on just what dogs say. Do some other kind of investigation, use another tool as well. Don't just clear it from the dogs. So did I answer your question?
Yes, I think so, Diane. Thank you.
Okay.
We have a few questions in the chat, but everyone, I'd like to give you a chance to interact with Diane as well. So if you'd prefer to unmute yourself and ask your question yourself,
yes, please do.
Totally fine. And we don't have to have me read it. Dallas Long, do you want to go ahead and ask your question?
Sure. Well, I think Jeff and I actually had the same question, which is, the man who had multiple gunshots and he survived for a time, and the ridge of the gunshot wounds had begun to smooth out. How long does that process take for the bones to heal or smooth out a bit?
We can microscopically start to see signs of healing in really, really thin bone, like around the teeth, around the alveolus of the tooth, within 3-4 days, something like that. But to have that kind of healing around those massive gunshot wounds, and the cranial bones actually, fairly thick in that area, it would take a long time. You're talking probably months to years.
Mhm.
So that man survived a pretty long time with those injuries then.
He did. It's amazing. He and the train victim, the guy who was hit by the train, I cannot believe, it always amazes me that I'll see one person with an injury like that gunshot wound that has obvious signs of significant healing. And then you see somebody else with barely a ding on the cranium and they're dead. It just is, it's just odd to me.
Yeah, pretty amazing the differences there. ZJ, I believe you have a question.
Yes, Dr. France, fascinating presentation. Thank you very much.
Thank you.
I'm wondering if you have any opinions on a case like JFK or with his exit and entry wounds, and any thoughts along those lines?
I'd love to be able to see the evidence. Without the evidence, I'm going on the same kind of information that you all are, the photographs from the videos and all that stuff. I really don't have, I don't have an educated opinion about it. I just don't know enough about it to be able to say. It would be, this will never happen, but it would be really interesting to be able to see the remains, or at least see the x-rays and the photographs, to be able to see, what kind of damage you have. Do I think that it is reasonable to think that one bullet can go through many different layers of skin and bone and still have the kind of power? I think with the rifle that he was using, it's entirely possible. But I can't tell you. I just don't know.
Thank you.
Sue Hinken, I believe you have a question.
Yes, hi. I was wondering how deep you have to bury a body to make sure a typical scavenger, coyote, fox or whatever, doesn't get to that body. How deep must a body be buried? Is it 6 feet, or what's the
No, we have done some research on that. Neck Research has a research site south of Littleton, about 5 acres. And we started trying to determine decomposition patterns, but also what we really wanted to do is bury bodies at different depths so that we could determine how deep ground penetrating radar is effective, and how deep we can find something with electromagnetic instruments and things like that. And it was just really weird. We left some bodies on the surface or buried in very, very shallow graves. We buried pigs. We did not want to go through the state anatomical board to get permission to become a body farm. We just didn't have the personnel to stay on site all the time and keep track of human bodies. And so we buried some pigs in a very, very shallow burial, and we buried other pigs at various depths. And one pig we buried to about 4 feet deep, which is a deep grave for a clandestine grave. But we buried him about 4 feet deep and then put a chain link fence over it. When we came back in about a week, the pigs in the shallow graves were untouched, and coyotes had gone underneath that chain link fence and got down to that pig and completely cleaned that pig out of the grave.
Wow.
We had no idea what's
Wow.
going on with that. But yeah, it was just bizarre. So I said that 4 feet would be a really deep grave for a clandestine grave, unless you are using heavy equipment. And we do get cases like that, but unless you're using heavy equipment, for somebody to dig a grave when they're trying to get rid of the body. Now this supposes that the person did not go out there and dig a grave with the intention that they're going to go back and kill somebody and then bring them back and bury them and have the grave all prepared. But if you have somebody who's trying to get rid of that person and trying to get out of there without anybody having suspicions about them and what's going on over in the woods over there with a flashlight going, then 3 feet is the deepest we have ever encountered a hand dug grave.
Interesting.
Yeah, and I do have that case actually, if you want to see the slides on that too, but I do have that case. But yeah, usually it's the kind of situation where you've got the hand sticking up out of the grave because it's so
Okay.
shallow. And then the coyotes and bears and so on are getting it. The scavenging patterns of different animals are interesting too. The scavenging patterns of coyotes versus bears, for example, and depending on how fresh the body is, we had one case up in the mountains where a bear had come along and completely removed a woman other than her dentures and a thumbnail from the grave.
Wow.
It dragged her, and bears will drag a body sometimes. Well, coyotes will go a quarter of a mile for parts of a body. They don't drag an entire body that far, but a bear can drag a body a mile.
Wow. Very interesting. Thank you.
Mhm.
All right. Anyone else have some questions?
I have a question. So I write
Okay.
for children, and so I'm always interested in the child's point of view. So Dr. France, I'm interested in at what point in your life you woke up and said, this is the kind of thing you wanted to study or you wanted to look into.
I grew up in the mountains of Colorado. I grew up in Walden. For those of you who are from Colorado, my dad was the doctor up there, so he had a skeleton hanging in his office. And I was half a block away from a hayfield. And so, and then that hayfield, you could walk for 40 miles and never see another person. And so I used to take my dad's microscope when he was golfing Wednesday afternoons. I took his old brass microscope that I still have up in the shelf up behind me, and take it out into the hayfields and look at things in the irrigation ditches. So I wanted to be a marine biologist. I was fascinated with dolphins and whales, and I wanted to be a marine biologist. It's kind of a weird thing for somebody in the middle of a landlocked state to be interested in. But so I went to college, went to CSU, and the second semester I had an opportunity to take an elective course and took an anthropology course. And I walked into the lab and saw skeletons laying out on the table, and the professor started talking about the kinds of things that you could determine by looking at the skeleton. And I changed my major that day. And I've never looked back. I still love dolphins and whales, and I still love looking at that kind of thing. But yeah, I was hooked.
That's a great story. Thank you.
Yes. Yes, very interesting. I believe Sabrina Caldwell had her hand raised. She has a question.
I did. Thank you, Margaret. Diane, thank you so much for a fascinating presentation. I learned so
thank
many
you.
things I had never known about before. I had a question. You know, we're all coming from the perspective of mystery writers, and one of the things that I'm interested in is when somebody dies from having fallen from a height. Are there any ways in which the bones can tell us anything about whether or not this person just fell or got a hand in it?
Yeah, you have touched upon the foolproof way to kill somebody. As long as you don't hit them with something that will leave a patterned injury first, as long as you don't hit them with a hammer, a claw hammer or something like that to cause them to go over the edge, as long as you just push that individual over the edge, all that blunt trauma in there, I can't tell you that it was from anything other than rocks. And that is actually, that's the dilemma that I was in with the henthorn case in Colorado. But Rocky Mountain National Park, this fellow's second wife died on him. The first wife died underneath a car when the jack suddenly failed. And the second case was when his wife mysteriously went off a cliff in Rocky Mountain National Park. And they asked me, can you determine, what killed her? And I said, not unless there was some kind of a pattern injury, or, you have toxicology kinds of tests and things like that, but to try to determine blunt trauma in that situation. It would be a really unusual situation to be able to determine the difference. It could be done. I mean, it's like with the barbell situation, the barbell shaft. If you found those kinds of injuries, that's not something that would be caused by a rock.
Mhm.
So
Mhm. I believe that case you were just talking about was on Dateline or 2020 or one of these documentaries.
I think it was.
Yeah,
Yeah, I think it was.
yeah.
Mhm.
But the guy got caught.
Yep, he did. Well, he shouldn't have done it twice, you know?
Yeah, really. Some people just don't think.
Yeah.
Other
Lucky for
ques-
us.
Yeah, yeah, isn't that the truth? Other questions?
Can I ask a
Do
follow-up
you have
question?
any? Sure.
Sure.
Thanks. So I actually had a few questions about this whole falling thing. The second one was, if somebody fell and broke something that caused them to die, but they didn't die right away, is there anything in particular that would cause that you could see later?
They
Like
break something.
I can imagine somebody maybe getting their cranium cracked and it didn't kill them straight away. So there's
Yes.
one thing. Are there
Oh,
any other things?
Well, the cranium, the Civil War case that I showed you with the cranium on the outside is perfectly fine, and it took him days to die. I mean, that could be a situation that you could be looking at. And in fact, I mean, that's one of the situations that you get if a little kid is hit in the head with a baseball. You're not seeing any kind of an injury on the outside of the cranium, but the inside of the cranium has a slow bleed. So you could have something like that, just to have a really slow hemorrhage. So you could do that. I mean, any kind of fracture, I won't say any kind of fracture, many kinds of fractures, you can have that fracture and somebody will just be, are you talking about maybe having them lying there suffering in the outside in the environment someplace and
That's
they
exactly
just
it.
slowly die?
Yeah.
You could, a really good way to do that would be if you broke the skin and you got an infection.
Oh, okay.
So you could have that kind of a situation where you are seeing the infection in the bone, and you may even see a little bit of healing. If you broke something like, for example, the scapula is a really, really thin bone. That's the shoulder blade. It's a very, very thin bone. It would be easy to break it. But it is also thin enough that you would be able to see signs of healing after maybe a few days. So you could have this individual have this fracture and survive suffering for a few days, and you would potentially see signs of healing.
Thank you.
Mhm.
Okay, other questions? Any other questions? Well, I believe we are at our 1 hour length. So I think we will say thank you very much, Dr. France,
Well, you are
for being
welcome.
here with us tonight.
Yep, it was a lot of fun. Thank you very much.
Oh, we appreciate it so much. Fascinating presentation. I hope
you.
you'll come back sometime,
Sure.
maybe next year.
Okay, you bet. Sure, we can talk about neck research, or we can talk about something else. Sure.
Oh, one quick question before I say goodnight. How do people initiate the necrosearch process? How is that initiated?
Okay, so we only take, like I say, we only take cases from law enforcement because we don't
Okay.
want to compromise any cases. And there is a group out there called themselves ECRISearch, and they do take cases from anybody. And they wanted to take one of our classes one time. We just said, no, we don't have anything to do with you. You're a bunch of ambulance chasers. And so we only take requests from law enforcement. When they call us and they tell us a little bit about the case, then we send them a questionnaire, a 4-page questionnaire to tell us about the case. Tell us about, first of all, tell us about the weight of the victim versus the weight of the suspect. Because if the weight of the victim is really high, the suspect won't be able to carry that person very far. There are other kinds of rules of thumb. A perpetrator will carry a body downhill farther than uphill. You will bury a body more deeply in soft soil than in hard soil. Just all kinds of common sense kinds of things that you don't normally think about until you're really focused on looking for these bodies. We've had perpetrators, by the way, who have completely stymied our search because they've broken all those rules. It's just, but anyway, those are the really interesting cases. Anyway, so we send out the 4-page questionnaire, they send it back to us, and it has all kinds of, what have you done to search here before? What day did the suspect or did the victim go missing? In part, we want to know, we'll talk to our meteorologist and say, was the moon full that day? How much light did the perpetrator have to bury this body? We're doing more work now with looking at car filters, where we have a botanist who is really interested in looking at car filters and looking at the plant types that are in the car filters to try to narrow down the place where the car has been, so we can start our search there. So anyway, they fill out this extensive questionnaire, and then we ask them questions back and forth, and they present to our group, and then we have kind of a roundtable discussion, which is one of the best parts of necrosearch, is the fact that we get to bounce ideas off of all these different experts and say, well, what can ground penetrating radar do for us here? And hey, what was the weather then? And scavenging patterns, what kind of scavengers are in the area, that sort of thing. And we do this all over the world. I mean, we've been to Australia, we have an ongoing case in Russia, England, Canada, Mexico, all over the United States. And the neat thing about necrosearch is that unless we actually respond to the scene and help them search in person, it usually doesn't cost them a thing. So all of this work that we're doing with them, it costs them nothing to do this. When we go to a scene, we only ask for reimbursement of our expenses, and that's it. Just, transportation, lodging, food, and that's it. We have almost all of our own equipment by now. We had a benefactor who just bought us a brand new, gorgeous $1,000 drone that we use on cases. It has infrared on it as regular light cameras on it. Fantastic. So then, we come up with a plan. We usually say, well, why don't you go out and get current aerial photographs? We have a computer expert who can take aerial photographs from 2 years ago to 1 year ago to today and interlay them so that he can subtract out everything that is common between those photographs and leaves with only what is different about them. So he can pick out graves that way. We do aerial photographs and look at botany to see what kind of botanical changes there are. Cheatgrass, those of you who are familiar with cheatgrass know that it grows very, very quickly, and it goes to seed very quickly. And so in the spring, if you have a disturbed site, if you just have a disturbed area like a grave, then cheatgrass can come in. It's an invasive species, and it can come in and start to grow. And if you do an aerial photograph in spring, like about this time of year, when the cheatgrass is just going to seed, once it starts going to seed, it starts turning brown, and it will pinpoint an area of disturbed ground like you just spray painted the scene. It's amazing. It's just so vivid, the difference. So we have a lot of different things that in our arsenal that we can throw at a site. And so we just converse back and forth, and then finally they'll say, well, are you busy in June? And so we'll schedule a time when we can actually go out there and work with them.
Very.
We never charge anything for our time. We only charge for our expenses. And that changes when the case actually goes to court. We will prepare them, we'll help them take it to court. We go to court, we testify. We will charge for our time in the testimony, but we don't charge for our time any other time.
Oh, very, very interesting. Very good. One more quick question from Mike here. What can ground penetrating radar do?
You know, it's thought to be this amazing tool, and it is an amazing tool, but it never finds bodies. There was a case, John Wayne Gacy case, as a matter of fact, when a geophysicist went out with GPR and said that he ran it over John Wayne Gacy's backyard, and he said, oh yes, here's a body right here, here's the head, and here's the body, and there's the shoe. And it turned out to be a pipe plate and something else. It wasn't a body at all. Ground penetrating radar never finds bodies. GPR only finds anomalies. So what you're looking for is actually the grave. You're not looking for a body, you're looking for the grave. And the way that you can find it, and with any of these geophysical techniques, either you're looking at the hydrological changes, you're looking at, the soil density differences, that kind of thing. You're looking for a grave where dirt has been taken out and then body put in and then dirt thrown back in. What you're looking for is that less dense dirt as compared to the surrounding dirt around it, around the grave. And if you see that, then we do things, we do like a little test trench, we can do probing, that sort of thing. But ground penetrating radar is not very effective if you have really rocky soil. If you have big boulders, that kind of thing, it's worthless. If you have a lot of big tree roots, there's just no point in even using it. However, if you're looking for a body that has been missing for 6 months, you don't look under 100-year-old trees for it. So the fact that GPR isn't very effective in big tree roots, sometimes it just doesn't matter, because you don't find a body there without causing some damage to the roots or causing some damage to the tree. So.
Oh, Diane, thank you again.
You're welcome. You're welcome. By the way, there is a book that's written about us, about necrosearch, actually several, but one is Steve Jackson's.
Okay.
Steve Jackson wrote No Stone Unturned, and it talks about some of these different techniques for finding bodies.
Oh, perfect. No Stone Unturned by
Right.
Steve Jackson.
Right.
Thank you.
You're welcome.
In the chat, we have a comment from Sabrina talking about necrosearch, saying super project, how good of you to do it. And we have just multiple comments thanking you for your presentation and telling you what an awesome presentation it was.
Well, thank you. Thank you. I appreciate that. That's very nice of you. I appreciate that.
Yes. And thank you so much. And good night.
Good night. It's my pleasure. Bye-bye. Have a good night.
Bye-bye.